Hello, everyone, and welcome to this talk on Introduction to Health Informatics, Artificial Intelligence, and Machine Learning. So, a bit about me. My name is A.B. Matthews, and I am professionally trained as a dentist. I also have a postgraduate diploma in Health Informatics from George Brown College. I am currently working as the IRSN coordinator at Access Alliance, and I'm also working as a Health Information Quality Assurance Analyst at MedChart INC here in Toronto. So let's have a look at the contents that we'll be covering in this talk. We'll cover an introduction to health informatics, artificial intelligence, and machine learning. We'll look at the potential use cases within healthcare for AI and machine learning. We will also look at the current applications that are there, including some case studies, and we will also look at the benefits and challenges, and we'll proceed to concluding this talk. Okay, so introduction. What is health informatics, artificial intelligence, and machine learning? Artificial intelligence, or AI, it's a broad scientific discipline that combines philosophy, mathematics, and computer science to understand and develop systems that display properties of intelligence. Machine learning, on the other hand, is a subdiscipline of AI, applying statistical models to data using computer algorithms, computer programs such as algorithms. Health informatics is the use of information technology to organize and analyze health records to improve healthcare outcomes. So basically, artificial intelligence is the umbrella term here, under which comes machine learning, and then inside which there would be deep learning. We'll talk about that in the coming slides. Health informatics is the application of all these tools, not only these tools, other tools as well, and conventional software development also comes under this in the healthcare context. All right. So let's have a look at the type of health informatics that are available out there. We have clinical research informatics, where we focus on clinical research aspects. We have imaging informatics, where medical images are analyzed and used for training better predictive algorithms and things like that. We have public health informatics, where we are looking at the health of the population as a whole. We have community health informatics when we are looking at community-based studies and things like that, where we will have more of a community-based approach for informatics. We have home health informatics. This is comparatively a new foray for informatics. In the recent days, we have seen a large increase in the number of, say, smart homes and smart devices within our households. So all this information that is being pulled on by these devices, and basically using those information, categorizing it, analyzing it, and arriving at conclusions based from that is home health informatics. We have nursing informatics, we have medical informatics, we have consumer health informatics. And now consumer health informatics is very important because this has actually enabled us to collect a lot more information in the recent times than what was possible before. If you think of, say, an Apple Watch, Google Fit, or a Fitbit, or things like that, we are constantly collecting information about ourselves and our bodies, and the state of our minds as well. So this all falls under consumer health informatics, and this also includes things like your um, if it's a smart device, your pregnancy test, your glucose monitoring, and things like that as well. We have clinical bioinformatics, where we are looking at the genetic structure and the information encoded within the genetic material itself. That's where the DNA analysis and splicing and then things like that come into play. We have pharmacy informatics, where we are looking at the general trend of usage of medicines, and that we are trying to predict how it is affecting human health in general, as well as veterinary health. We this that falls under the pharmacy informatics part. A comparatively new foray in informatics is the use of informatics for education and research in health and medicine. So here we are looking at, say, published research, and using things like NLP, text processing and things like that to understand what are the current research that is going on, and then trying to get that into application and day-to-day practice as soon as possible. So here, what we are trying to achieve is to reduce the time that is being taken from research to be well established, and then it actually being brought back into practice. So these are the different types of health informatics that are out there. No, this is in no way an exclusive list. We have a lot more, but these are the main. All right. So now let's go ahead and look at the practical applications of AI and machine learning. The practical applications include speech recognition, facial recognition, autonomous driving, recommender systems, and so on and so forth. So if you talk about speech recognition, say you say, "Hey Alexa," and the system recognizes it's you. So that's speech recognition for you. There's more application to this, including security, access control, and things like that. We have facial recognition, which can be used for a lot of things, including security, and but not limited to just that. We even if to just unlock your laptop. Now the laptop camera can turn on, look at your face, and recognize you, and your phone as well. Autonomous driving, if we talk about it, you have the best example of the Tesla. Not only Tesla, but a lot of companies are trying to get a head start in that domain. But as we all know, Tesla is way ahead of the game, and I do believe that that's going to be the future. Recommender systems, if you talk about it, we have the best example in Netflix. So it's very interesting because Netflix might be knowing more about your viewing preferences than you. Their systems are that good, and based on which, if you can see, there are no shows that are being released on Netflix that basically tanks. A movie being released in the theaters and the movie actually tanking, that is no longer a phenomenon that is observed on Netflix. Everything is a success because they know so much about you and your viewing patterns. They can custom make a Netflix original series based on that input. So that's pretty interesting. Now we have image classification where a gazillion images can be classified into categories, which can be used later to enable machine learning and then things like that. If you see, for example, on Facebook, auto tagging of your friends and you, that's all based on this. And the systems are able to automatically identify that it is you, your friends, and then the tagging can be done. There's a lot of applications for this in medicine as well. If you think about it, if you have a x-ray or a histopathology slide, if you're looking for a carcinoma and if the system can better identify it, these applications already exist, and we will go into that in detail in the coming slides. Then we have natural language processing, where the intent and nuance of the language itself is being analyzed, and the systems are getting better in understanding that and being able to communicate with us. Now, another thing that is very interesting is the automated or assisted diagnosis. This has a huge impact on medicine, where we may be able to say see an increase in efficiency in hospitals at least. So that's that. Let's have a short discussion on algorithms now. Algorithms is a computer program or procedure or formula used for solving recurrent problems based on conducting a sequence of actions. So basically, it is the step-by-step breakdown of what you want to do or how you do it, so that desired outcome is materialized. So for machine learning, these are the various algorithms that we use. We use support vector machines, neural networks, logistic regression, discriminant analysis, random forest, linear regression, naive biases, and so on and so forth. There are a lot, and these are the major algorithms that are actually used. All right, now let's quickly look at the processes of getting an AI system in place. The first one is data collection. Machine learning and AI systems require lots of data, and this is important as these systems feed on data to become more and more accurate and efficient. Now, second step is data preparation, because if you think about it, 80% of almost all healthcare data is unstructured. So the machine learning algorithms and systems need structured data. They need to define a data element and identify that, okay, this is this and nothing else. So ambiguity in terms of, say, for example, if you're writing Ontario, you can write O capital letters and then NTARIO in small. or you can write everything in small, everything in caps, or you can just write ON. Being a human, when you look at it, you understand all of this refer to Ontario, but the system won't understand that. So standardization is key. Now, the third step would be the training and testing. In the stage, the machine learning algorithms can be trained and tested, and then they can be deployed. The fourth step is the robust machine learning models implemented generates an artificial intelligence outcome. So here I would like to I always like to say artificial intelligence is an emergent phenomenon. So basically a lot of things going on, and the intelligence is emerging out of it. So that's the key here. Okay, so till now we have been talking about data like a lot. So I thought let's go ahead and see how much data we are actually talking about. So the global data creation is actually projected to hit 2,142 zettabytes by 2035. So to understand the scale, one zettabyte is equal to about a billion terabytes. So one TB or a terabyte is about a hard disk. So imagine a billion of them, and then 2,000 times that. So that much of data is being created, um, will be created by 2035. So you can see that from 2010 on all the way projected up to 2035, you can see the data creation is increasing manifold. It is actually 48% of increase per year. The reason why this is happening is because of the increase in computing power that we have at this point, and because of the creation of data that is being that is going on for the longest period of time. Okay, so uh, moving on to the specifically to the healthcare sector. If you look at the growth in healthcare data, um, in 2013 it was 153 exabytes. By 2020 it is now 2,314 exabytes. So this is not a zettabyte. This is a different scale. The biggest issue that we face these days in healthcare is not about the lack of data, but rather how we are going to store it. So the storage capacity, there is a discrepancy between the storage capacity and the actual data being produced in healthcare. You can see that about 985 exabytes of data are only being stored at this point. That is our storage capacity. We have about 2,314 exabytes of data to be dealt with. So that's a challenge that we are facing now. All this a huge increase in data and data amount is basically due to a multitude of reasons. And remember when I said consumer health informatics, at this point we have about 4.9 million patients worldwide who are actually, it's way more than that. This is stat of 2016. In 2016, 4.9 million patients were using remote monitoring, and an estimated 18% of annual compound growth rate was actually anticipated between 2010 and 2016 for persons who use monitoring devices. Given the current circumstances around COVID-19, this rate has gone way more, and that has also contributed to the rapid increase in terms of data. Okay, now let's look at some use cases within healthcare for all these, right? See, the first one would be robotic surgery. So this benefits a lot because distance is no longer an issue. If you have a robotic operating center, a surgeon from across the continent would be able to do that kind of surgery, and this may, in time, save a lot of lives. Now, for nursing assistants, we can have intelligent chatbots that provide support for patients in terms of triaging and in terms of better organizing the entire footfall of the hospital. For medical diagnosis, we can see AI algorithms have been proven to outperform physicians in many ways. I want to reiterate here that it is not innate intelligence of the systems; it's just a brute force capacity and the ways in which they process the information. The criteria setting should be accurate for the results to come out accurate. The fourth one would be image analysis. You can see cloud computing and AI together helps to analyze image for better results, and we can understand a lot about, say, for example, a carcinoma or classification of cancer very accurately with image analysis and AI coupled together. Point number five would be workflow assistance. AI can help to make clinical and clerical jobs way more easier. We can always give the repeated jobs to the systems, and then um, the workforce that is made free from those duties can be used for what actually matters, which being caring to the needy and the patients. Okay. In terms of clinical trials, we have performing predictive analysis to understand which molecules are better suited for this a specific condition that we are looking at, and things like that. We'll come to that in the next slide. Okay. Let's quickly look at the current applications that are there. I want to just explain about these four companies and products which caught my eye. There are many more, but these ones were pretty interesting, so I thought I'll put them here. Path AI, it's a system that it's a company that assists pathologists in making more accurate diagnoses. So they Path AI, they have a project called Project Saturn, where they are looking at 69 billion molecules to understand and to better, get um, making more accurate predictions. Truth, on the other hand, is a sepsis early warning system implemented in Johns Hopkins University. So, sepsis is a silent killer, and the key is that it's very hard to identify. So, once sepsis is started, time is of the essence, and every hour wasted understanding or identifying a sepsis case would increase the mortality rate by 20%. So this system, which was the truth system, which was developed at Johns Hopkins University, they implemented it into their EMR, and then the system constantly monitors every reading of the patient, and then provide an early warning into if the patient is susceptible for sepsis. So after implementation of this, the prediction window went up to 12 hours, which ended up saving a lot of lives. These systems are still implemented and are being currently implemented in various systems in the US. The next two companies, Deep Genomics and Babylon Health, these are based out of Toronto. Deep Genomics basically helps to identify candidates for developmental drugs related to neuromuscular and neurodegenerative disorders. So they look at again a lot of possible molecules that can be made into a drug, and they basically enable to shorten the time within the drug development life cycle. Babylon Health uses their AI to provide personalized and interactive healthcare to its clients. They have an app. If you go in and log in, and when you talk to that app, basically saying what is your condition, symptoms, etc. It's actually an AI which is talking to you, and it'll categorize you, and it'll determine if you need a doctor's visit and things like that. Okay, so these are the various companies which are in health informatics. Companies like Epic, Cerner, Meditech, and Sunnybrook. These are all EMR vendors. We have other companies as well, like Prescribe IT. They basically integrate the pharmacy systems into EHR. It's Canada system. We have MedChart, who is working with health records. We have Smile CDR. That's also a case record which is integrated for health record usage. All right. Let's quickly move on to the current applications. These are the companies that, if you're interested in this field, please keep an eye out for. You have IBM Watson, we have Google DeepMind, and we have iCarbonX. All these are important companies. Please follow them on LinkedIn or go to their websites. There's a ton of information there, which will really help you to understand where the current state of things are. All right, let's quickly look at the benefits and challenges. Um, Benefits of AI in healthcare. First of all, it enables better data-driven decisions. There is no error of guesswork. Second, it increases the diagnostic efficiency. The third is it basically reduces the hospital visits and thereby reducing the wait times. It also helps in time saving by reducing or making the administrative task simple or easier to handle, basically. Right. So, what are the challenges of implementation? So, we have the first major challenge is data privacy and security. We have the various mobile applications working in this field. We have a lack of inoperability, interoperability issues, and all those things. This is primarily a concern in I would say in the private sector. When it comes to healthcare in Canada, as it is publicly funded, there's a high level of scrutiny for the systems that are used in the hospitals. And that's a good thing. We have integration difficulties. We can see that there's a lack of, or say, there is resistance to adaptation of these issues by clinicians. It can be due to a multitude of reasons because their established workflow changes or they are resistant to change and things like that. This is fear of replacing humans, which I do not agree to. The whole idea of AI should be to assist or better enable humans to do a better job rather than replacing humans altogether. The third major thing is the ethical issues. Who is to blame upon an error if it happens? So that's very interesting because suddenly with AI systems and machine learning systems, this has become a great deal of concern, and everybody's very interested in this at this point in time. It requires a talk on itself, and probably will one day do that. Okay, there's data reliance as well. As I told before, for AI system to work, we need more and more of data. So if you're not inputting the right amount of data in the initial stage, and if you're not training the systems well, the systems will not give optimal results. So that's something that also need to be considered. If you want to pursue a career in this field, health informatics, machine learning, or AI, you have education opportunities here in Ontario in all these institutes. University of Toronto has a master's in health informatics. Georgetown College has a PG diploma in health informatics. All these programs are great. IRSN University has multiple programs in big data, data analysis, AI, and things like that. All these programs are great. You can just go to their website, do a small search, and there's all the information that is required available on their websites. So, to conclude, the important thing is that we need to understand that a diverse range of tasks can be done by AI. We can automate back office functions. We can communicate. We can better communicate with patients with AI. We can develop more practical treatments. The repetitive work can be avoided. We can also do monitoring and diagnosing for patients. Right. Um, that's all great. It's also important to note that AI can do errors. Given insufficient training data, these systems can malfunction. There's also a threat of misuse of this, and AI systems could be weaponized, and that also needs to be considered. And there are IT malfunctions which are out of our control, which may threaten the integrity of the systems. So, in terms of machine learning, I always like to quote Suchi Saria, who is a professor of machine learning in Johns Hopkins University. She says, everyone has heard about big data. In reality, there is a lack of specific data of you to make an accurate predictions. And there lies the challenge of machine learning because randomizing data and understanding the patterns, that's one thing. But understanding more and more data about you, that would be the crux of all of this, and we'd be able to come out with better predictions. So with that, this presentation is done. Thank you for tuning in and thank you for listening. If you have any questions, please feel free to reach out to me. I'll be more than happy to help you in any regard that I can. If you have any questions, you can always reach out to me on email or on the IRSN platform. And hope to see you on the next one. Thank you.